A student asked me an interesting question today, so this screencast is an answer to that question about markup. In this word problem, Billy buys used bikes, blah, 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 and he marks up the price by 80%. He fixes them and then he marks the price 80% to make money. He has salesmen or salespeople sell them for him and they get a commission of 25%. And a student noticed that as we did this table, as we found the markup by doing 80% of the buying price and then taking the commission on that markup, that every time we did that, the commission here was actually always the same as the buying price minus the markup. So in this answer it was $10 and 8 was the markup, and the commission, which was given at 25%, would be 2. And so he noticed that in all of the problems here, if you do the buying price minus the markup, you would get this answer, and he wasn't sure why. So I wanted to show you first how we could have gotten, how we're supposed to get the answer would be, we're supposed to be taking the markup is 80% of the buying price. So the markup we're trying to find is 80%, so that's 0.80 times the buying price. And if I did that, I would get 8. So in this case, the markup is $8. And then I'm supposed to be calculating the commission. I skipped this one. Calculating the commission is always, the commission is 25% of the markup. So to find the commission, I would do 0.25 times the markup, which is in this case 8. And so that would give you $2. Well, you notice that 10 minus 8 is 2. So here's mathematically why that's true. Here's our hypothesis. We've noticed that the commission always equals the buying price minus the markup. And we want to know why is this true? Why is this working in this problem? It doesn't work in every problem, but it works in this one. And so why is that true? Well, to find the markup, we do 0.80 times the buying price. And to find the commission, you do 0.25 times the markup. So what we're going to do is we're going to exchange these here so that we only have one variable in our equation. So we have so many variables and so many equations here. So if I go off of what I know here, so what I'm going to do is I'm going to take this here that I know the markup is 80% of the buying price, and I'm going to put that 0.8 and I'm going to exchange it for this M, so that what I'll have is to find the commission. If I only knew the buying price, I could still find the commission by, I always multiply 25% times the markup. Well, the markup is always 0.8 or the buying price. So I'm going to simplify this and put 0.25 times 0.8. So 0.25 times 0.80 is 0.2. So what that means is 25% of 80% is 20%. So if the markup is 80% of the buying price and the commission is 25% of the markup, then the commission is actually 20% of the buying price. So I'm going to use this new equation that we found and this equation that we already had, that the commission is 0.25 of the markup, and I'm going to solve these two things backwards. So I'm going to write them in terms of C. So I'm going to solve this equation so that M is on the other side of the equal sign. So I'm going to divide both sides by 0.25. Dividing by 0.25, so 1 divided by 0.25 is 4. So that means that 4 times C equals M. So let me make sure that you understand. If the commission was if how am I trying to say this? If the markup was $1, then the commission would be 25 cents. Okay? So you would need 4 of these to make 1 of these. So if I'm saying that if the markup is 1/4 of the commission, then the commission is 4 times bigger than the markup. So if the commission was 25 cents, the markup would be $1. I'd probably not explain that correctly, but just trust me. So if I divide over here, divide both sides by 0.2, I can either have C divided by 0.2 equals B, but a better way to write that would be 5 times C. So if I divide something, if I divide 1 by 0.2, and you might be saying, where's the 1 coming from? Remember the invisible 1? So 1 times C, so 1 divided by 0.2, so 1 divided by 0.2 is 5. So that's why it ends up being that the buying price is 5 times the commission. All right, so putting this all together, let's go back to what we had before. The markup is 4 times the commission. The buying price is 5 times the commission. We're going to take these two facts and we're going to go back to our hypothesis at the beginning. Remember we said that the commission always seems to be the buying price minus the markup. So when the buying price was $100 and the markup was $80, the commission was $20, which is true in this table. So let's see why that is algebraically. Well, remember that the markup is 4 times the commission. So where I see markup, I'm going to write 4 times the commission. Right? Isn't 4 times 20, 80? The buying price is 5 times the commission. So where I see buying price, I'm going to write 5 times the commission. Isn't 5 times 20, 100? And when I subtract these two things, what's 5 C's? Take away 4 C's, 1 C. And we get that, yes, it is true that the commission, in this case, because of the percentages we're using, in this case, the commission is always the buying price minus the markup. But that's only because of this first relationship, these two facts here, that 80% of the buying price is the markup and 25% of the markup is the commission. And because those working together, it ends up being this final relationship that someone noticed in the table. All right, thanks.